Welcome to Maths for All. I'm Aisling Flynn. This is Trigonometry 1.5, the area of a triangle. Area of a triangle. Well, we've calculated the area of a triangle before when we knew various measurements, for example, the base length here of this triangle and what's known as the perpendicular height. We could calculate the area by area equals half the base by perpendicular height. Okay, when we did coordinate geometry, we had a version of this as well, where we could use the coordinates of points on a triangle provided one of the points were 0, 0, and we could calculate the area, which was equal to half of the absolute value of x1 y2 minus x2 y1. Again, note this factor of a half, so they're linked. And today we're going to use trigonometry to calculate the area of a triangle. So if we were to know, for example, the perpendicular height here and the base along the bottom, I'm going to call that A for now. Okay. The area would be simply half of the base, which is A, times the perpendicular height H. Okay. Now we're in trigonometry here, and we want to relate the area to the angles, etc. So I call the base there little a, so the angle opposite will be big A. All right. Now you don't need to know where this comes from, but I'm just explaining where the formula on the next page or the next slide comes from. Okay, let's call this angle B. Okay, and this angle C. Now the angle in question in this formula is angle C. So I want you to focus at that for a moment. That means that the side opposite here would be little c, and the side opposite angle B would be little b. All right. Now focus on angle C here again. All right. And what I want to do is I want to relate this H, which we won't be provided with in the following questions, and I want to relate that to angle C. Okay, and you can see that that H is part of a right angle triangle here that includes angle C and side B, where B is the hypotenuse. Okay, and H is opposite angle C. So there we're talking about opposite and hypotenuse. If you think back to your ratios, we can see that when we have opposite and hypotenuse, we can use the sine ratio. So we can say that sine C, sine of the angle C, is opposite, which is H, over hypotenuse, which is B. And if we alter that ever so slightly, multiply both sides by B, we'll get B sine C on the left, and we'll get H on the right. And this here can be used to replace H in this formula. Okay, so that's where the formula on the next page comes from. In trigonometry, we're going to use for this the area of a triangle half A times B sine C. All right, so again, you don't need to know where it comes from, but it helps. So here you have that formula in trigonometry for the area of a triangle. We can use area equals a half AB sine C. So you saw with the sine rule and the cosine rule that the labeling of your triangle is important so that you put the right figures in the right place, and the same is here. So for the area formula, the angle in question is called angle C. And as always, the side opposite that is little c, and we don't really use this, or we're not using this in this calculation for area. So the measurements that you will be using will be the two sides that are adjacent to angle C, that are touching it or that make up angle C. That's side A, which is opposite angle A, and side B, that is opposite angle B. Okay, so what you need to use this formula is any angle and the two sides that make that angle. When you need to use it, if you want to check you have it correctly, you can go to the trigonometry pages, page 16 of your formula and tables book, trigonometry of the triangle, and you'll see the area formula. It's available here. So let's put that into practice and let's find the area of this triangle shown here on the right. And you'll need your calculators at hand. Okay, find the area of the triangle shown on the right. So you would look at this triangle, you'd see that you don't have a perpendicular height, that you are provided with an angle. So straight away I'm thinking trigonometry, and I would go to my formula and tables books and I would write down the formula for area. A equals half AB sine C. Next I would look at my diagram and I would start to label. So the angle in question is sine C, that's 46. The side opposite it is little c, and so the other two are A and B, 7 and 8. Alright, so that's sorted. Now we just have to substitute the correct numbers. So we'll have a half multiplied by 7 multiplied by 8 multiplied by sine of 46 degrees. Okay, now take a moment to check that your calculator is in the degree mode. There's a little D or DEG at the top of the screen, and then you can type it in exactly as you see it. So I'm typing a half using my fraction button, or you can type 0.5 multiplied by 7 multiplied by 8 multiplied by sine 46, press equals, and I get 20.1415, and it does go on a bit. It's not specified how many decimal places I need. I think I'll leave it at 2. So 20.14 and square units, whatever they were, maybe it's centimeters squared or meters squared, doesn't say. Alright, so formula, label, substitute, and then calculate. Let's practice a little more. Some of these are straightforward, some aren't. Find the area of each of these triangles in centimeters squared correct to the nearest whole number. Okay, so I'm going to write my formula up here in the corner. Half AB sine C, and we'll do question 1. So firstly, the angle in question is C, and on either side of that will be A and B. Doesn't matter which one is A or which one is B. Okay, so I'm going to, for question 1, fill in the correct numbers in the correct place. So half times 7.8 times 6.4 times sine 28 degrees. Calculator now. So we're multiplying half by 7.8 by 6.4 by, and I missed a decimal point there, just double check your screen on your calculator, times sine 28, and I get 11.718. 11.718, and the question said to the nearest whole number, so that is closer to 12 than it is to 11 because the next digit is 7, so I'll say 12 centimeters squared. Okay, that's part 1. Now question 2, let's have a look. So we have our formula. Now we have two angles here, 38 and 48. Which one do I use? What I need are the two sides, or the two lengths of sides either side of the angles. Now I don't have that for 38. I only have the 11, and I don't have it for 48 either. I only have the 9. I do have two sides for this top angle, but I don't know that. However, I can use my knowledge of the triangle that all the angles should add up to 180 degrees. I can find out that angle C. Okay, so if I take 180 degrees and I subtract the other two angles, I can find what angle C is. So 180 minus 38 minus 48, and I get 94 degrees. So angle C is 94 degrees, and let's let 11 be A and 9 be B. Okay, and we'll just fill in our numbers now. Half AB, so half times 11 times 9 times sine C, that will be sine 94 degrees. So on to my calculator now. Half times 11 times 9 times sine 94 equals, and I get 49.379, correct to the nearest whole number. The next digit is 3, so it's closer to 49 than 50. So 49 centimeters squared is my answer. Question 3. Okay, we have a similar situation here. We don't have the two sides to make angle 28. We don't have the two sides to make angle 120. We do have the two sides for this missing angle here, which we will call our C. And again, we can calculate that knowing that the three angles in a triangle add up to 180 degrees. So if we take away 28 and 120, we'll get our angle C. So 180 minus 28 minus 120 is 32 degrees. So C is 32 degrees. Let's let 23 be A and let's let 14 be B. And filling in my area formula, half times A times B times sine C, which is 32. Calculator now. Half times 23 times 14 times sine 32 equals, and I got area equals 85.317. Again, correct to the nearest whole number. We're less than halfway, so area is equal to 85 centimeters squared. Now, look at this question. Find the area of this parallelogram correct to the nearest centimeter squared. And we're given a hint to help us along. A parallelogram can be treated as two equal triangles. So if we draw a line along the diagonal as shown, okay, we can find the area of one triangle and we can double it to get the area of the second one and get the whole lot. Okay, so our angle here is 70. That will be our angle C. All right, do we have the lengths of the sides that make that angle 70? Well, we have 24. It doesn't appear that we have this side, but the fact that we have a parallelogram, we know that opposite sides are equal, so this one here must be 15 centimeters also. Okay, so writing down my formula, half AB sine C. So our C is 70 degrees. Let's let 15 be A and 24 be B. Fill in your numbers. Half times 15 times 24 times sine 70. And we'll calculate that. Okay, and I got 169.14. Now that gives the area for one of those triangles, and so we'll multiply by 2 and we'll get the area of the parallelogram, which is 169.14 by 2, and I get 338.28 correct to the nearest centimetre squared was what was asked. We'll say area equals 338 because it's less than halfway centimetres squared. Okay. Incidentally, if you choose to multiply by the 2 first from your formula, you'll get, you counteract the half. 2 times a half is just 1. So we could have begun with area of a parallelogram equals to, so no half, just AB sine C, and we get to the answer straight away. Now, this is a working backwards type question where we're asked to find a missing angle, but using the same area formula. If the area of the given triangle is 40 centimeters squared, find the angle A correct to the nearest degree. So the area of this blue triangle is 40 centimeters squared. So we're given the answer to the area calculation. We have an angle here, A, and we have the lengths of the two sides adjacent to it, or that make that angle. Okay, so we're going to start by writing down our formula, half AB sine C. Okay, we're going to do the next step, which is to label our formula. So in this formula, the angle in question is called angle C. So in fact, what's called A here now, we're going to call angle C, and the sides adjacent to it will be A and B. Okay, so let us fill in the information we have. Okay, A is 40, half is 0.5, or half, multiplied by A is 10, multiply B is 14, multiplied by sine C. Okay, so you can see that the only unknown here is angle C, so and we have an equation, so it should be solvable. Firstly, let's simplify some of the numbers. So multiplying the half by the 10 by the 14, you should get 70. And 70 times sine C is what we have on the right hand side. We're going to isolate the sine C next. We're going to divide left and right by 70, because 70 divided by 70 is 1. And 40 divided by 70 is 0.57. I'll write as much as I can in. 0.5714. And so now we have the result for a sine C. How do we go and find the angle C? How many degrees? Well, there we go to working backwards. We use our sine inverse function. So shift and the sine button, type in 0.5714, and this should give us angle C. All right. C equals 34.85 degrees, and the question said to the nearest degree, so that would be nearest to 35 degrees because of the 0.8. It's more than halfway. Now you can practice some work on that with the quiz and your written exercises.